Have you ever wondered where time, the invisible ruler of our lives, originated from? This seemingly simple question opens up a world of thought and exploration that has captivated philosophers, scientists, and curious minds for centuries. Time, as we understand it, is more than just the ticking of a clock. It's a dimension, much like the three dimensions of space we live in. It's a fundamental aspect of our universe woven into the fabric of reality itself. Just as we move through space, we also move through time second by second, minute by minute, from the cradle to the grave. But unlike space, we can't change the direction of our journey through time. We can't revisit yesterday or leap into next year. We're all passengers on a one-way trip, and that's the way it's always been. Yet, time isn't as straightforward as it appears. Philosophers have pondered its nature for millennia. Is time a river, flowing relentlessly from the future into the past? Or is it an illusion, a construct of our minds to make sense of the world? On the other hand, physicists have their own interpretations. Einstein's theory of relativity tells us that time and space are interconnected, forming a four-dimensional space-time continuum. It also tells us that time is not absolute, but relative, depending on your speed and the strength of gravity around you. And then there's the quantum realm, where the conventional rules of time seem to break down. Here, particles can exist in multiple places at once, and effects can precede their causes. This strange world has given birth to concepts like quantum entanglement and superposition, challenging our understanding of time. So where does this leave us? Well, it seems that time, much like the universe itself, is a grand tapestry woven from threads of philosophy, science, and the human experience. It's a mystery that we're still unraveling piece by piece. To understand time, we must first embark on a journey back to the very beginning, to the birth of the universe itself. The beginning of time is traced back to a singular event known as the Big Bang, an event so monumental that it marked the inception of everything we know and perceive. But what was the Big Bang, and how did it give birth to time, space, and matter? Imagine a point of infinite density and temperature, a singularity. This was the state of the universe before the Big Bang. Then, in an instant, this singularity began expanding. This was not an explosion in the conventional sense, but rather an expansion of space itself. This moment marked the birth of the universe and the dawn of time. But how do we know this? It's thanks to the cosmic microwave background radiation, the afterglow of the Big Bang, still detectable today. When we peer into space, we are essentially looking back in time, observing this primordial light. In the immediate aftermath of the Big Bang, the universe was incredibly hot and dense. As it expanded, it cooled, allowing for the formation of subatomic particles. These particles eventually grouped together to form atoms, the building blocks of matter. This was the first step in the creation of everything we see around us today. Space, too, came into existence with the Big Bang. Before this event, there was no space for matter to exist in. The Big Bang created space and set it expanding, a process that continues to this day. The universe as we know it is not static but constantly growing and evolving, a testament to the power and legacy of the Big Bang. In this way, the Big Bang was not just an event, but the beginning of a process that led to the creation of galaxies, stars, planets, and eventually life itself. The birth of the universe marked the birth of time, setting in motion the cosmic clock that has been ticking ever since. Thus began the cosmic clock, ticking away since the moment of the Big Bang. As time marched on, the universe expanded and galaxies started to form. Picture this, an infant universe, a vast expanse of hot, dense matter. As the universe cooled, this matter began to clump together under the relentless pull of gravity. This was the beginning of a cosmic ballet, choreographed by the laws of physics. In the early stages, these clumps of matter were tiny, no larger than a grain of sand, but over millions of years they grew, merging and colliding, forming larger and larger structures. These were the building blocks of the galaxies we see today. This process, known as hierarchical clustering, is a bit like rolling a snowball down a hill. As it rolls, it picks up more snow, growing larger and larger. In the same way, these clumps of matter grew, picking up more matter as they moved through the universe. But how did these clumps of matter transform into the galaxies we see today? Well, the answer lies in the laws of physics. As these structures grew, they began to spin. This spin, combined with gravity, flattened them into disks, much like a pizza dough spinning in the air. In the center of these disks, the matter was densest. Here, stars began to form, their light piercing the early universe. Around them, more stars formed, creating a bright central region we now know as a galaxy's bulge. Meanwhile, in the outer regions of the disk, stars formed in smaller numbers. These areas, known as the spiral arms, are where new stars are still being born today. And so galaxies, these majestic islands of stars, gas, and dust, took shape. But the formation of galaxies was more than just an aesthetic spectacle. It marked a crucial point in the evolution of the universe. For the first time, matter was organized on a large scale. The universe had structure, it had form, and it had a way to create new stars, planets, and perhaps life. Galaxies, the grand structures of the cosmos, were the first to keep time in the universe. Within these galaxies, stars ignited, and around them, planets were born. Imagine the universe as a cosmic nursery, brimming with clouds of dust and gas known as nebulae. These nebulae are the birthplaces of stars. Over millions of years, the force of gravity pulls these particles together, compressing them into a dense core. As this core grows, pressure and temperature inside it rise, igniting nuclear fusion, the process that fuels a star. This is the birth of a star, a process that unfolds over millions of years, just as fascinating as the birth of planets. Planets form around stars in a process called accretion. Tiny particles of dust and rock, remnants from the birth of a star, begin to collide and stick together. Over time, these clumps grow larger, forming planetesimals, the building blocks of planets. Eventually, these planetesimals combine to form planets, each revolving around its parent star. This process, too, takes millions of years. Time, then, is at the heart of these celestial births. The universe doesn't rush, it takes its time, crafting each star, each planet with meticulous patience. But stars, like all things in the universe, have a life cycle. They spend the majority of their lives in a stable state, fusing hydrogen into helium. This phase, known as the main sequence, can last billions of years. Eventually, though, the star exhausts its hydrogen supply and it begins to die. Depending on its size, it might swell into a red giant or explode in a brilliant supernova. The death of a star is as dramatic as its birth, and it's a testament to the cyclical nature of the cosmos. Stars die, but the remnants can seed the birth of new stars and planets, continuing the cosmic cycle of birth and death. Stars and planets, like giant cosmic clocks, mark the passage of time in the universe. Each tick, each tock, is a celestial event, a testament to the intricate dance of the cosmos that has been unfolding since the beginning of time. On at least one of these planets, life emerged, bringing with it a new perception of time. Our blue marble, Earth, cradled in the vast cosmic ocean, was the stage for an incredible drama. The emergence of life, a complex dance of chemistry, began to unfold over billions of years. Tiny, single-celled organisms multiplied and evolved, eventually giving rise to a dizzying array of forms, from the smallest bacteria to the largest dinosaurs, and ultimately, to us, human beings. As life evolved, so too did its perception of time. For the earliest life forms, time was dictated by simple biological rhythms, like the cycle of day and night, or the changing seasons. These natural rhythms were the first timekeepers, guiding the behavior and evolution of countless species. Then, something remarkable happened. Human beings evolved. Unlike other creatures, we developed a sophisticated awareness of time. We began to perceive time not just as an unending cycle of days and nights, but as a linear progression, a journey from the past through the present into the future. We invented calendars and clocks, tools to measure and track the passage of time with astonishing precision. We began to conceive of time in terms of seconds, minutes, hours, days, years, centuries. We used this newfound understanding to build civilizations, to predict the future, to record the past. Our perception of time has shaped our history, our cultures, our very identities. But at the same time, our understanding of time has been shaped by the cosmos. The cycles of the moon, the motion of the planets, the lifespan of stars. These cosmic phenomena have informed our concept of time, reminding us of our place in the grand cosmic scheme. And so time, as we understand it, is not just a human construct, it is a cosmic phenomenon, a fundamental aspect of the universe we inhabit. Thus, we see that our perception of time is a result of cosmic evolution. As we look forward, we realize that time, like the universe, is ever expanding. As we journey further into the cosmos, we encounter notions that challenge our understanding of reality. The future of time, much like its origins, remains a mystery that science continues to unravel. It's a vast and exciting frontier that pushes the boundaries of our knowledge and imagination. theories abound about what the future holds for our universe and the concept of time. One of the most prominent is the Big Freeze theory. This suggests that as the universe continues to expand, it will eventually become too spread out to sustain processes that require energy, including life itself. Time, as we perceive it, would still continue. But in a universe devoid of change and motion, would it have any meaning? Another theory, the Big Crunch, proposes a more dramatic end. It posits that the universe might one day stop expanding and start contracting. In this scenario, time could potentially reverse, leading to a universe that shrinks rather than expands. Yet, another theory considers the existence of a multiverse, a collection of universes including our own. If this is the case, each universe could have its own unique version of time, potentially with different rules and behaviors. Understanding these theories and the nature of time itself can help us predict the future, not just of our universe, but possibly of others as well. It allows us to prepare for what lies ahead, even if these events are billions of years in the making. However, it's important to remember that these are just theories, each with its own set of assumptions and limitations. As our understanding of the universe evolves, so too will our theories about its future and the nature of time. As we gaze into the future, we are reminded that time, the ever-flowing river, waits for no one. Despite our best efforts to understand and predict it, time marches on, carrying us along on its relentless current towards the future. Our journey from the Big Bang to the present has been a voyage through time itself. We've traversed epochs, witnessing the unfolding of the universe from its fiery genesis to the cosmic spectacle that it is today. We started by probing the concept of time, delving into its complex nature. Time, as we learned, is not just an abstract idea or a mere measurement, it's the very fabric of our reality, the unseen dimension that governs the cosmos. We then journeyed back to the dawn of time, to the moment of the Big Bang. This was the point where time, space, and matter were born, a singularity exploding into existence, marking the start of everything we know and understand. We witnessed the formation of galaxies, massive cosmic structures that serve as the homes for stars, planets, and potentially life. These galaxies, like cosmic islands, were formed from primordial gas and dust, their beauty and complexity a testament to the laws of physics. Next, we delved into the birth of stars and planets. These celestial bodies are the result of cosmic alchemy formed through processes that have taken billions of years. They are the stage upon which the drama of life unfolds. We explored the emergence of life and how human perception of time has evolved. From the first stirrings of life in the primordial soup to the development of human consciousness, our understanding and perception of time have played a pivotal role in shaping our reality. And finally, we peered into the future of time. While the end of time remains a mystery, what we do know is that our universe and time itself is constantly evolving, forever moving forward. As we contemplate the mysteries of time, we realize that we are not just observers of this cosmic journey, but active participants in it. We are part of this grand cosmic ballet, dancing to the rhythm of time, from the Big Bang to the present day and beyond. Thank you, dear explorers, for joining us on this extraordinary journey through time. We hope this voyage has sparked your curiosity, and we encourage you to continue exploring the mysteries of the universe. Remember, while our understanding of time has grown exponentially, there is still much we do not know. Time remains a frontier, a vast expanse waiting to be discovered and understood. As we venture further into the cosmos, we must keep asking questions, keep seeking answers. As Carl Sagan once said, somewhere, something incredible is waiting to be known. We are all part of this grand cosmic journey, bound by the inexorable flow of time. As we continue to unravel the mysteries of the universe, let us remember the words of Albert Einstein. The distinction between the past, present, and future is only a stubbornly persistent illusion. So let's continue our journey, let's continue to explore, and let's continue to marvel at the wonders of time. Because after all, we are all time travelers, journeying together into the future. That's it for our journey through time, folks. We've traversed the birth of the universe, the formation of galaxies, the emergence of life, and even dared to speculate about the future of time. This cosmic voyage has been a testament to the grandeur and mystery of the universe and our place within it. Remember, time is a mystery that we're all a part of. It's not just something we observe, but something we live, something we experience. So keep exploring, keep questioning, and keep marveling at the wonders of the cosmos. If you've enjoyed this journey as much as we have, don't forget to like, share, and subscribe. Your support helps us continue to create content that feeds your curiosity and fuels your imagination. As we sign off from this voyage, we leave you with this thought. Time is the space in which we live, the stage upon which the drama of life unfolds. It's the canvas upon which we paint our dreams and memories. So, until our next cosmic voyage, keep your eyes on the stars and your feet on the ground. Safe travels, time travelers. Remember, we are all explorers, journeying together into the future. Until next time, keep exploring, keep dreaming, and keep wondering.